Yeah, welcome back. So, welcome back to the solution of the problem number of digits in a factorial. This might look very simple at onset, but there is some trickiness to it because like in computers, in programming languages like JavaScript, integers can take up only a maximum of certain number of numbers, right? There is a maximum value a number can go up to. So, we need to solve this by making use of the fact that there is a maximum value, and hence if you do it the usual way of doing factorial, this might be overflowing and sometimes you might have seen an error. So how are we gonna solve this? So let's first understand. For example, let's assume I'm giving a number something like 5 and its factorial is 120, right? So we need to return the number of digits, so the output is 3. Great. Now we already know counting digits and factorial, but that will not work out here. So how are we gonna solve this? This solving of this problem is based on this mathematical logic. So what that is that, for example, let's say number from 0 to 9 until 99 and 999 9999 and it goes on. 5. So what happens is, like, for the scale of these numbers, if you take this log of nums until this and this, it will be in the range of 0 to something like less than 1. Okay, from here it will be like from 1 to less than 2. So it goes on. So here it starts with 2 and it is less than 3. If you see, this log is always one number less than the, for example, if it is from 0 to 9, we know number of digits is 1, right? But it is always less than that. So it's something like point something. So it will be like we have one less digit. So what we will do is, like, we will add 1 plus this log of number. So this is what we are going to use it in our problem. Also, there is one more fact. The fact is that log of a into b is equal to log of a plus log of b. Okay, so we're making use of this couple of facts and gonna try to solve this problem. Let's see how we can do that. Okay, so coming back to the editor, let me create a new file. 13 num of digits in factorial. Okay, .js. Great. So now let me create the function number of digits in factorial, and this is going to take num as an argument, and let's initialize a variable number of digits is as 0. And now here comes the mathematical logic. For let I is equal to 1 and I is less than or equal to num. Okay, and then I plus plus. Inside this we usually multiply it, right? But if we multiply it for larger number of values, this may cause issues. For example, let's take, yeah, we will do an example, don't worry. So inside this I plus plus, now what I'm going to do is that num of digits is plus equal to math dot log 10. So this is how you used to find the log of number. So JavaScript provides this inbuilt method. So math dot log 10. That's why I said tricky. You need to know these facts about logarithm as well as this inbuilt function. So now we will pass I. Okay, and in the end we will just return 1 plus math dot floor of number of digits. Okay, yeah, number of digits, math dot floor. It will be something like some fractional value. You just add 1 to it. And now let's add some test cases. So console dot log number of digits in factorial, and let's pass 5, as well as let's say for the value 120. Now if you try to run this problem, node 13, yep, we get the right output. For example, factorial of 5 is 120, so we get 3, and for the factorial of 120 it has 199 digits. Just to make a point over here, let's go to this factorial.js file which we have already created, right? Now if I try to call this factorial recursive with that same number, right? What was that number? 120. Okay, so let me comment all other things. So node 03, you see it gives some kind of a value, but ideally if you try to run this in a browser or stuff, it will overflow, because this is a very big number, exponentiation number, which is like a very big number that can't be holded, and hence we need to make use of this fact of this logarithm, and usually we will multiply the factorial number, right? If for example I pass 5 into 4 into 3 into 2 into 1, but we are making use of this logarithm fact that log of a into b is equal to log a plus b, and hence we are doing a summation of it, and in the end we are adding 1 to it because it is always 1 digit less. So hence we are able to solve this problem. So the time complexity is that we go of n, and space complexity is we go of 1. Great. So see you in the next one.